Okay, that's all for transport layer. Now let's look at the network layer. Actually, network layer can set the connection between the process on host. So for example, here is the sender, here is the receiver, so they can establish the connection from the process in the sender through the routers until the process in the receiver. And there are two key functions in network layer. One is data forwarding. So every router needs to forward the data packet from one incoming link to the correct outgoing link. And another function for the network layer is to calculate the routing. For example, this is the source, this is destination. We have one path, we have another path, so the routers can work together to find out a best path and transmit the packet along this best path. So that means routing. So network layer protocols include the Internet Protocol version 4, version 6, and ICMP and also IGMP. Let's look at the detailed working process of a network layer protocol. Actually, first they will do the packet encapsulation and decapsulation. Actually, every layer will do this function. They will put the payload into a packet by adding some header and tail. But the most important function of network layer protocol is the packet forwarding. So first, for each router, they will using some routing protocols to calculate a correct route. For example, they will calculate the result and put it in a routing table. The routing table looks like this. This is the destination IP, and this is the corresponding outgoing interface. So for example, if we look at the router 1 for a packet whose destination belongs to the network A, it will tell you that, okay, the router 1 should forward this packet with this destination IP to this outgoing interface. So this packet should forward from this outgoing interface. And similarly, for this router, they will check its routing table and find that this packet with the destination IP should go from this link and go through this link and finally can arrive the destination. So this function check the outgoing interface and forward the packet to the interface means packet forwarding. This is the most important function in network layer protocol. Okay, now let's look at the data link layer. In data link layer, the message are in unit of frame. Okay, you may notice that at different layer, they have different name. So this is segment, this is datagram, and this is frame. Okay, so the data link layer actually locate between the network layer and physical layer, and they provide service for protocols such as TCP, IP, and IPv6 at the network layer. They provide service. So what kind of service? Actually, they can provide the intra-segment communication, and they can also provide the function of data link layer. For example, they can do the framing. They can cut a long packet into several small frames, and they can give the physical address for each packet, and they can do some basic error control. Typical data link layer protocols include Ethernet, PPPoE, and also PPP. So for link layer, one important concept is the MAC address. Okay, and a typical link layer protocol is Ethernet. The Ethernet actually is the wired local area network. So in the Ethernet, the computers can be connected with each other using the switch and finally to a router to connect to the internet. So in such a network, this is a broadcasting network. By using the Ethernet, any packet from the host can be broadcasted to the other hosts. And in Ethernet, you need to know that every node will have not only an IP address. The IP address is allocated from the network layer. And in link layer, we have another address. We call it the MAC address, the media access control address. And the MAC address actually cannot be changed for a device. The MAC address of a device actually is allocated and identified when this network interface card or when this device manufactured. After that, this MAC address cannot be changed. In contrast, the IP address can be changed. Okay, in which network the IP address can be changed to the IP of this network. So you can think of the MAC address as your ID number, and the IP address to be your postal address or postal number. And a device that works at the data link layer will be the switch. As there are two addresses, IP address and MAC address for one devices. So there is a natural question for a device, if we have already know its IP address, how do we know its MAC address? So to solve this problem, actually, we usually use this protocol called Address Resolution Protocol, ARP. ARP can discover the MAC address for a given IP address. So if there is a computer host A, he wants to transmit a packet to host B, but he only know the IP address of host B. He wants to know the MAC address because he needs to put the MAC address into the packet in the domain of the header. Then how can it know the MAC address? Actually, they can use this ARP request to ask for the MAC address of this IP. And then if host B can receive this message, he can reply with an ARP reply and write his own MAC address into this reply message. Then host A can know, oh yeah, for this IP address, the corresponding MAC address is like this. So this is the overall protocol, overall process for ARP protocol. But in detail, actually, the whole process are divided into several stages. So the first stage is that if originally, the host 1 have no items in its ARP table. Actually, every device will maintain an ARP table, but originally it is empty. So if we use this command to check, yeah, you can see that it's empty. Then he should request for the MAC address of this IP. Then he should send out a message. So this message actually is an ARP request. In ARP request, there are four domains, which is MAC1, IP1, the IP and MAC of the sender, and also the IP and MAC of the receiver. But as he doesn't know the MAC address of the receiver, so here they simply write all 0 here. And we need to add the MAC header. So for MAC header, they said that it is a broadcasting packet. So there is a broadcasting or one address written in the header. So this is the ARP request message. Then the ARP request message are sent out. Then if it reaches a switch, the switch should broadcast this message to all its connected hosts. And then the host 2 will receive this request. Then when host 2 receives the request, it will first check whether this request is for me. So they compare the destination IP address in this ARP request message with its own IP address. If they find that, yeah, it's for me, then I should reply with a message. And before reply with message, he should also add the match of host 1 into its ARP address table. So he will know that corresponding to this IP address, the MAC address is this one. So he will add this entry into the ARP table and then send back this ARP reply. So in this ARP reply, he will add his MAC address into this ARP message. Then the switch no longer broadcasts this ARP reply because for this switch, he has already know for this IP, the corresponding MAC address is here. So he can simply forward this message to host 1. And then host 1, after receive message, will finally add the corresponding relationship into its ARP table so that after this message, he know that whenever he want to transmit packet to this IP address, he can add the corresponding MAC address into the header. So that's all for the total ARP protocol implementation. So simply, you need to know that they should send a request and receive a response or reply. And every device will maintain an ARP table in its own memory.